Assalamu alaikum. Today we are going to see the topic Laplace transform. This is the part 1 in which we are going to see Laplace transform of some elementary functions, that is formulas. Okay. Before going to this topic, this is my YouTube channel Explore Maths with Abdul Azim Sir. Like, share, comment and subscribe to my channel. Now let us begin the topic. So first of all, define the Laplace transform of a function. So the answer will be, let f of t be a function of t defined for all real numbers t greater than or equal to 0. Then the Laplace transform of f of t is denoted by L of f of t and defined by L of f of t is equal to integration 0 to infinity e power of minus st f of t dt. Okay, this is the formula of Laplace transform. Mark it as first equation. So for this, provided the integral of the right side exists, and here this s, here s is a parameter which may be a real or complex number. The operation of multiplying f of t by e power of minus st and integrating from 0 to infinity is called Laplace transformation, or short Laplace transform. Now write the advantages of Laplace transform. So here we have three transformation uses. First advantage, the method of Laplace transform has the advantage of directly obtaining the solution of differential equations with given boundary values without the necessity of first finding the general solution and then evaluating from it the arbitrary constant. Moreover, the ready table of the Laplace transforms, like the tables of logarithms, reduces the problem of solving a differential equation to the algebraic process or problem. Next advantage, Laplace transform solves non-homogeneous differential equations without the necessity of first solving the corresponding homogeneous equation. Next advantage, Laplace transform is applicable not only to continuous function but also to piecewise continuous function, complicated periodic functions and step functions. So these are the advantages of Laplace transform. Now let us see Laplace transform of some elementary functions, that is formulas. So Laplace of k, constant Laplace of k is equal to k by s, where this s greater than 0 and k is a constant. For example 1, 5. So Laplace of 5, 5 by s. Next, Laplace of e power of at is equal to 1 by s minus a if s minus a greater than 0. Here note, Laplace transform does not exist when s less than or equal to a. Next, Laplace of e power of minus at is equal to 1 by s plus a if s plus a greater than 0. Okay. Next, Laplace of sin at is equal to a by s square plus a square if s greater than 0. Or we can write this sin at, Laplace of sin at, as hyperbolic. So Laplace of sin at is equal to Laplace of e power of iat minus of e power of minus a iat by 2i, where this we know that sin theta is equal to e power of it minus e power of minus it by 2 factorial. This is the hyperbolic form. Now Laplace of cos at is equal to s by s square plus a square, or we can write as e power of iat plus e power of minus ait by 2. Okay, where cos theta is equal to e power of I theta plus e power of minus I theta by 2. Okay, next Laplace of sin at, sin hyperbolic at is equal to a by s square minus a square, provided s greater than mod a. Next, Laplace of cos at, cos hyperbolic at is equal to s by s square minus a square if s greater than mod a. Okay. Next formula, Laplace of t power of n, that is n factorial by s power of n plus 1 if n is positive integer. For example, in place of n, put n is equal to 0. So t power of 0, any power of 0 is 1. So Laplace of 1 means 1 by s. Now put n is equal to 1, t power of 1 t. So Laplace of t is 1 by s. You substitute 2. So Laplace of t square is equal to 2 factorial by s power of 2 plus 1, that is 3. Likewise we can do. Now Laplace of t power of a, here it is t power of n number, and here t power of a is a real number. So formula is, this is the sign of gamma, gamma a plus 1 by s power of a plus 1, where this symbol gamma function, s greater than 0 and a is the real number. Next, Laplace of root t is equal to root of, in the numerator, root pi by denominator 2 into s power of 3 by 2. So Laplace of root t is equal to root pi by 2 power of s power of 3 by 2. Next, we have seen this gamma function. Now gamma function is gamma of n is equal to integration 0 to infinity e power of minus x into x power of n minus 1 into dx. So now see just the properties of gamma function. This gamma power of n plus 1 is equal to n into gamma n, where n greater than 0. This is also known as recurrence formula. Now gamma n plus 1 I can write as n factorial, where n is a positive integer. Gamma 1 by 2 is equal to root pi, and gamma minus 1 by 2 is equal to minus 2 root pi, and gamma 0 or gamma minus 1 or gamma minus 2 are not allowed. Okay, as we know that indeterminate form, 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power of 0, infinity power of 0. Now if this case will arise, we will use L'Hospital rule or L'Hospital rule. What is this? Limit extends to f of x by g of x if we substitute the limit, and if you get 0 by 0 or anything from this form, then what you have to do, limit extends to a, in the numerator derivative, in the denominator derivative. So limit extends to a f dash x by g dash of x. After that apply f dash a by g dash of a. Here if you get the answer, okay, otherwise this argument may be repeated till we not get both sides 0. Okay, so this is the regarding L'Hospital rule. Now next see the formulas. This is known as first shifting theorem, or first translation theorem. So what is this? If Laplace of f of t is equal to f bar of s, then Laplace of e of at f of t is equal to f bar of s minus a. Now application of this theorem. So Laplace of e power of at t power of n is equal to n factorial by s minus a power of n plus 1. Next, basing on this, we have formulae Laplace of e power of at sin bt is equal to b by s minus a whole square plus b square. If it is here positive, you will get negative. If it is negative, Laplace of e power of minus at sin bt is equal to b by s plus a whole square plus b square. Next, Laplace of e power of at cos bt. So the formula will be s minus a by s minus a whole square plus b square. If it is e power of at, this will be, if e power of minus at, so minus will become plus. So s plus a by s plus a whole square plus b square. Next, Laplace of e power of at sin bt, sin hyperbolic bt. So b by s minus a whole square minus b square. Likewise, minus is there. So Laplace of e power of minus at sin bt is equal to b by s plus a whole square minus b square. Next formula, Laplace of e power of at cos bt is equal to s minus a by s minus a whole square minus b square. Likewise, if it is minus, Laplace of e power of minus at cos bt is equal to s plus a by s plus a whole square minus b square. Okay. Now next, Heaviside unit function. Heaviside unit function, or sometimes it is known as unit step function. So here the unit step function u of t minus a is defined as u of t minus a is equal to 0 for t less than a and 1 for t greater than a. So where this a is always positive and this is the unit step function at t is equal to a. Okay. Now we have some formulae. Laplace of u of t minus a is equal to e power of minus as by s, and Laplace of u of t is equal to 1 by s. Here note, u of t minus a is also denoted by u of t or h of t minus a, Heaviside unit function. And second, f of t u of t minus a is equal to 0 if t less than a, and f of t for t greater than a. Okay, these are the formulas. Now next, second shifting theorem or second translation or Heaviside shifting theorem all have same meaning and same formula. If Laplace of f of t is equal to f bar of s and g of t is equal to 0 if t less than a and f of t minus a if t greater than a, then Laplace of g of t is equal to e power of minus as f prime of f bar of s. And another form of shifting theorem, this, if Laplace of f of t is equal to f bar of s, then Laplace of f of t minus a into u of t minus a, that is equal to e power of minus f of s, where u of t minus a is the unit step function f bar here. Next formulas, change of scale property. If Laplace f of t is equal to f bar of s, then Laplace of f of at is equal to 1 by a f of s by a. Similarly, Laplace of f of t is equal to f bar of s, then Laplace of f of t by a is equal to a into f of s by a f bar. Laplace transform of derivatives. So if Laplace of first derivative, Laplace of f dash of t is equal to s into f bar of s minus f of 0. Next, Laplace of fn of t is equal to s power of n f bar of s minus s into n minus a f of 0 minus s power of n minus 2 f dash of 0 up to so on f power of n minus 1 into 0. Here note, Laplace of fn of t is equal to s power of n f bar of s if f of 0 is equal to 0, f dash of 0 is equal to 0, f double dash of 0 equal to 0, and so on, f of n minus 1 of 0 is equal to 0. Okay. Now next formula, multiplication by power of t. So if Laplace of f of t is equal to f bar of s, then Laplace of t into f of t is equal to minus of d by ds f bar of s. Okay, this is power multiplication of power t. Likewise, multiplication by t power of n. If Laplace of f of t is equal to f bar of s, then Laplace of t power of n f of t is equal to minus 1 power of n d power of n by ds power of n into f bar of s, where n is equal to 1, 2, 3 up to so on. Next, here we have note one, that Libni's rule. So if f of x comma alpha and dou by dou x of f of x comma alpha are continuous, see here it is mentioned continuous. So are continuous function of x, then alpha is equal to d by d alpha integration a to b f of x comma alpha dx, that is integration a to b dou by dou alpha f of x comma alpha into dx. Okay. So these are the formulas for Laplace transformation. Again, this is my YouTube channel, Explore Maths with Abdul Aziz Sir. Like, share, comment and subscribe to my channel. So that's all.